My sombrero.
Remember when we found the area under a curve on a graph? Well, now we're going to learn how to find the area between two curves. If f and g are continuous on a to b, and g of x is less than f of x for all values of x, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is found by solving this formula. This formula can be better understood as the integration from a to b of f of x minus the integration from a to b of g of x. Now that we have learned the formula, let's try a practice problem. Find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x, x equals 0, and x equals 1. This is the graph of the equations, and the area we are trying to find is marked by the green shaded section. Now we take the formula we learned previously and we plug in the values that are given. That'll look like area equals the integral from 0 to 1, x squared plus 2 minus negative x. Now we're just left with simple integration. We all know how to do this by now, and so you end up with x cubed over 3 plus x squared over 2 plus 2x. And then you just plug in the 1 and the 0 and subtract the 0 from the 1. And you get the values 1/3 plus 1/2 plus 2. And this all equals 17 over 6. And that is your final area. Using the area formula, we can also find the area of a region bounded by two graphs. Let's try to find the area of the region bounded by f of x equals 2 minus x squared and g of x equals x. The graph of this is located here. Now before we begin with the area formula, we must solve for a and b. A is marked right here and b over here. That is the intersection between the two graphs. So we begin by equating the two of them together. So 2 minus x squared equals x. We simplify this, move them all to the same side, and get negative x squared minus x plus 2 equals 0. We can factor this down into negative x plus 2 times x minus 1 equals 0. From here we just solve for x, and we get x equals 2 and x equals 1. So from this, a equals negative 2 and b equals 1.
My sombrero.
Now that we have our a and our b values, we can plug them in along with the f of x and the g of x into the area formula. So after plugging them in, we arrive at this equation. We integrate and we arrive at negative x cubed over 3 minus x squared plus 2 plus 2x from the values of negative 2 to 1. We plug in the negative 2 and subtract it from after we plugged in the 1, and we arrive at our final solution, which is 9/2. Now we are going to explain how to find the area between two curves that intersect at more than 2 points. Our two equations are f of x equals 3x cubed minus x squared minus 10x, and g of x equals negative x squared plus 2x. The graph of this looks like this. As you can see, it intersects at 3 points instead of just 2. This graph is labeled f of x, and this is g of x. The shaded region is what we are going to solve for. We begin by equating the two equations to each other. So 3x cubed minus x squared minus 10x equals negative x squared plus 2x. After we solve for x, this will give us the 3 points where the graphs intersect. After some computations, we arrive at 3x times x plus 2 times x minus 2 equals 0. After we solve for those values, we get x equals negative 2, 0, and 2. Because we have 3 points of intersection, we must use two area formulas in order to find the total area that is bounded by the graphs. First, we find the area from A to B. And because f of x is larger than g of x from A to B, we are subtracting g of x from f of x. Next, we have to find the area from B to C. And because in this case, g of x is larger than f of x on the interval from B to C, so we are subtracting f of x from g of x. So all we do after that is we plug in the values that we have attained. First, a equals negative 2, b equals 0. We plug in that. That is our interval. Then we plug in the values for f of x and g of x. Next, we plug in the values for the second area equation, and we have from the interval of from 0 to 2, b and c. And then we put in g of x minus f of x. Now that we have all the numbers plugged in, we just integrate, and we arrive at 3x to the 4th over 4 minus 6x squared from the interval of negative 2 to 0, and plus negative 3x to the 4th divided by 4 plus 6x squared from the interval 0 to 2. We plug in the negative 2 and the 0 here, and the 0 and the 2 over here, and we arrive at 24 eventually after you simplify the entire equation. So just remember, when you have 3 points of intersection, you will have two different area formulas to find the total area. We are now going to learn how to solve equations that are in the x equals form. Here is our two equations we have, 3 minus y squared and y plus 1. The shaded region in blue is what we are trying to find. To begin, we find the points of intersection between the two graphs. That's at A and B. We do this by equating the equations together. After we do this, we find that the intersection points are at negative 2 and 1. Now that we have the points of intersection, we plug in all the parts just like we've done in the past for the area formula. We do this by plugging in the points of intersection, the lower number, -2, and the upper number, 1. And then we, instead of taking the higher graph minus the lower graph, we take the graph that is to the right minus the graph that is to the left. In this case, the f of x, which is 3 minus y squared, is the graph that is furthest most on the left, or on the right, excuse me. And so we put that one first, and we subtract g of x from that. From here, it is the same as we've done in the past. We integrate and then plug in -2 and 1, and from there we receive our answer of 9/2.